Hello everyone, I'm Ben Armstrong. I'm a program manager working on the core team at Windows working on virtualization. And here today I want to try and do a really quick run through of everything that's new in Hyper-V in Windows Server 2016. Before I get started, how many people here are using Hyper-V today? Show of hands. Fantastic, that's what I love to see. So how many people are on 2012 R2 in their deployments? Okay, great. Do we have any 2008 R2 out there still? Couple of people, okay. I will say this session is really focused on what's changed between 2012 R2 and 2016. So we've got a bunch of material out there talking about, one, the differences between 2008 R2 and 2012 R2. Also, I'm going to be talking a bit about upgrade. One of the things I do want to be really clear with anyone who has any 2008 R2 or 2012 in their environment is that your best upgrade experience is going to be to upgrade those machines first to 2012 R2 and then from 2012 to 2016. And I'll step through that as I'm going through. Now, one of the things I do like to start this session off with is to highlight, for a lot of people here, you go like, Hyper-V 2012, 2012 R2 were huge releases, and they really were. This is actually the feature list. It auto-clicked on. So this is the feature list from 2012 R2 and 2012 compared to 2008 R2. And then this adds in everything we've done in 2016. So 2016 is another huge release for us. It's one of the reasons why I say I'm going to be screaming through. We actually did, at the end of last year, I worked with, and my slides are auto-advancing, and I don't know why. That's annoying. End of last year, I actually worked with our technical marketing team. We did an 8-hour virtual academy talking just about what's new in Windows Server 2016. I need to figure out how to stop that auto-advancing. That's really irritating. OK, we'll see how we go. So I actually have a link at the end of this session to that 8-hour virtual academy. But I do just want to be upfront. There's going to be a lot of stuff here which I'm going to talk about. I'm going to spend a couple of minutes, and you're going to have a lot of questions. I don't have enough time to go deep. He's going to see if he can fix the auto-advancing, because it is determined to keep on going. So I'm going to just be doing a very high level. I'm going to be pointing you to resources. If you have more questions, please feel free to find me afterwards. Look up the resources online. So while he's figuring that out, the first topic that we have to discuss is security. And this has been a huge area of investment for us. And it's been a huge area of investment because one of the big things that we've found when talking to people is we've been talking to people a lot about, hey, cloud computing's the way of the future. You want to be looking at hybrid cloud, you want to be looking at public cloud. And one of the top concerns that people have been coming back with is they've been saying, I'm not sure I can trust my data in someone else's cloud environment. And this has been a big focus for us for a number of years. And we have a whole set of technology that we're coming out with to address that. And I do want to be crystal clear, we've been hearing that feedback and we've been taking it to heart. And do I have slides? Awesome. And one of the things, actually, here's a show of hands. How many people feel like they've been talking about, compute security for over a decade now? Good people. But one of the things I do want to take a moment to highlight is, you can go out, you can do the research, you can look at the data. There is no question in the industry that the security landscape is actively getting worse. The reality is that we are seeing a higher level of security attacks. We're seeing higher sophistication in security attacks. We're seeing higher levels of funding for people doing security attacks. So there are those of us, and certainly I can remember back in 1999 working for the Australian government, finding out that they had a whole bunch of workstations with public IP addresses on the internet. That was fantastic. Literally, the janitor's computer had a public IP address doing a security audit. But the security landscape continues to get worse. And so there's a number of technologies that we're bringing to market with Windows Server 2016. The first one is a suite of technology that we call Shielded Virtual Machine. And Shielded Virtual Machine, the goal of Shielded Virtual Machine is to allow you to put your workloads in a public or a hosted cloud and guarantee that no one can tamper with your data. And Shielded Virtual Machine is built up of 3 core technologies. The first one is that we're allowing you now to put a TPM into your virtual machine, a virtual TPM. So why is that useful? That's useful because now you can use BitLocker inside that virtual machine to encrypt the data on that virtual machine so that if someone gets access to the virtual hard drive, they don't get access to your virtual machine. So that's the first part of Shielded Virtual Machine. The second part of Shielded Virtual Machine is what we call the actual shielding technology. And the shielding technology, there's a number of components in here, but the effect of the shielding technology is we make it so that the host administrator on the Hyper-V server cannot actually access that virtual machine. So if you think about a situation where you have a hoster providing a virtual machine to you, yeah, they can see the virtual machine's there, they can see it's running, but we don't give them access to the console. We protect that virtual machine process from other things in the host operating system. We actually make it so that if someone who's an admin on the box were to attempt to try and attach a debugger to that virtual machine, they can't. So the shielding comes in and provides the extra layer of protection. The final part of this is the Host Guardian service. And the Host Guardian service is a off-box service that is responsible for ensuring the health and security of the actual Hyper-V host before it starts up a shielded virtual machine. And when we bring these 3 things together, we feel that we can provide a really strong promise for people of, hey, you can take your virtual machine and you can run it in a public cloud environment, in a hosted environment, and you can guarantee that people don't have access to the data on that virtual machine. On top of that, we're providing a solution for Generation 1 virtual machines which don't have the virtual TPM. Now this is not shielding, and it is not as strong as shielding, but when we talked to a lot of people, they came back and said, hey, the shielded virtual machine story is really cool, however, we have workloads that don't run in Generation 2 virtual machines, and all we need is we have a regulatory compliance requirement to say that our data is encrypted at rest. So that's where we have this solution, the key storage drive for Generation 1 virtual machines. It allows you to use BitLocker in a Generation 1 virtual machine, but it doesn't provide the full shielded virtual machine story. The next thing we've done, this is actually a show of hands. How many people here have read about the Windows 10 Credential Guard technology? Not many people. This is insanely cool technology that I'm really proud to be part of. So we delivered this first last year in Windows 10 in the Enterprise SKU. And what Credential Guard does is it utilizes the Windows hypervisor to provide ultimate protection of your credentials on a Windows box. And if you go online, I don't have time to demo all this today, but you can see we've pre-recorded demos where we actually show someone logging in with a Windows 10 machine and launching malware as an administrative user and elevating the process, and that malware is still unable to get access to the user's credentials and use it maliciously because we're protecting those credentials with the hypervisor. So that's hugely powerful technology that we shipped last year on Windows 10 Desktop. The 2 things that I'm really happy to say about Windows Server 2016, the first one is that we're enabling this technology on all SKUs of Windows Server 2016. And honestly, if you take nothing else aside, go read about Credential Guard and enable it on your servers. Because I wish people didn't browse the web on their servers. I wish people didn't get malware on their servers. They do. And this is technology that ensures that when that compromise happens, people can't get access to your credentials. The second thing though, and I'll show you this in a moment, is that we now support running this technology inside of virtual machines. And it's actually really easy to enable inside of virtual machines. It's like setting 3 register keys, and then you have this amazing level of protection of your credentials inside virtual machines. We've also done a bunch of work to enable secure boot inside Linux virtual machines. So another show of hands. How many people here are familiar with secure boot, know what it does? This always makes me angry because I've joked to the kernel guys. I'm like, I feel like if there's nothing else I could do, it'd be to go out and evangelize the great work that we did with secure boot, because I don't think we did a good job of selling it. So secure boot is a technology that we released in Windows 8 and Windows Server 2012. So let me turn this question around. How many people here know what a rootkit is? Yeah, rootkit, and rootkits are bad. If you get a rootkit on a box, genuinely your only option is to format wipe, burn the warehouse down, like run away screaming, because you can't trust that system anymore. And secure boot is technology that we designed to combat rootkits. And in a nutshell, what secure boot does is it allows us to sign key kernel mode components, and when we boot Windows, we go through and we make sure that those kernel mode components have not been tampered with at all, so that if someone tries to install a rootkit, we just stop the box from booting. We go, this box has been compromised and it should not boot anymore. And when you have secure boot enabled, you have a guarantee that all kernel mode components are from Microsoft. Well, what about Linux? So we've had a whole a huge effort engaging with Linux community, with various Linux vendors, to bring secure boot over to Linux. So what does this mean, you might ask? What it means is I can now create a virtual machine that, say I intend to run Red Hat or Ubuntu or a Linux distribution from a vendor that I trust. I can go into that virtual machine and say, enable secure boot, and use the certificate that's used for Linux distributions. And then when I boot up that virtual machine, I know that I am running code that came from the vendor that I trust, and not some random code that's being compiled by someone who I don't know. So a great way to ensure that your systems are compliant and they haven't been tampered with. The final thing to talk about in security, this is kind of an amusing story, is a functionality that we call host resource protection. And one of the things I'm going to talk about a bit is there's a bunch of times that we build features specifically for Azure. They're one of our biggest customers. And a lot of times these features we then turn around and productize and make it part of the Windows Server that you guys get. And sometimes it's great, sometimes it's a little bit subtle. This is one of those subtle ones. This may come as a surprise to people here, but people try and hack Azure. 24/7, we have people buying virtual machines and trying to figure out how to break into the Azure fabric. Thankfully, no one's ever succeeded at this. But one of the things that the Azure team came to us and talked to us about was like, hey, it's great that no one's ever succeeded in breaking out of a Hyper-V virtual machine, but what we have noticed is when they are trying to hack Azure, they can really suck up a lot of resources. We get people running random kernel mode code and hammering on things, and it causes performance issues. And so what we did was we worked with the Azure team to come up with a set of algorithms where we could start to identify no well-behaving software should be doing this inside a virtual machine. And if we see these patterns, because maybe it is well-behaving software, maybe it is intended, what we do is we let it run, we just throttle back the resource usage. And we just slow down that virtual machine so it doesn't affect other virtual machines in the environment. Now, this is actually shipping in Windows Server 2016. Hopefully, you'll never see this. If you do see this, you can actually see in the Hyper-V event logs, and the Hyper-V UI will come up and say, host resource protection enabled. My favorite story about this feature, though, was that when we first put this out in the build, about 2 weeks later, we got a very angry email from someone you might know, a fellow called Mark Krasinovich, because we broke all his demos. he has this great session that he does on hunting malware, where he has a set of virtual machines that are just overflowing with all the nastiest malware in the world, and he shows how you go through and triage it. Well, when we rolled this technology out, it caused performance issues for his demo, because all of a sudden we're detecting this and we're slowing down his virtual machines. So if you are Mark Russinovich, there is actually a registry key to go in and you can turn this off, but for the rest of the world, you want to leave this on. So let's quickly switch across. I'm going to go lighter on demos in this session than I would like, just to try and keep things in time. I do want to show some of the virtual machine protection and shielded virtual machine technology. So the first thing I'm going to do is I'm going to bring up, this is a Generation 1 virtual machine where I've enabled the key storage drive and I've enabled BitLocker. So this is just a nice, simple solution. Log in, and if I bring up the PC for this, there are going to be two things that you're going to see. The first thing you're going to see is there's a floppy drive. That's what tells you that it's a Generation 1 virtual machine. We don't have those in Generation 2 virtual machines. And the second one is that I have BitLocker enabled. And I have BitLocker enabled. We have a feature which is the key storage drive. If I bring up the settings, you'll see I have a key storage drive attached. And what the key storage drive is we create a little like 40 meg drive that we attach to the virtual machine. Inside the virtual machine, you can use that to store your BitLocker keys in. And on the host side, we automatically encrypt and protect that data so that people can't get access to it. So that's the key storage drive. Moving over, though, to the virtual TPM solution with a Generation 2 virtual machine. So I'll bring up the settings here. You can see that on this one, if I go to the Security tab, I've enabled the TPM. I haven't enabled a bunch of the advanced security features because, as I mentioned, one of the things about shielded virtual machine is it stops the administrator from interacting with the virtual machine. That makes this the world's most boring demo. I can bring up a blank VM Connect session and be like, there's a VM there, and it's not letting me do anything with it. We actually have done a number of full-length sessions just talking about shielded virtual machine. I'd really encourage that people look at that. But I'm going to bring up a couple of things here. The first thing is you can see my PC. I have BitLocker enabled on this. The next one is if I go into Device Manager, you can see I have my TPM here, which is what I use to protect this virtual machine. And the final thing is if I bring up sysinfo, I just want to show that this does have Credential Guard enabled on it. And as I said, I'd really encourage, if nothing else, go out, read up about Credential Guard. It's a great feature for protecting credentials, both in server and desktop environments. The question was, is that going to lower SKUs of Windows 10 anytime? And the answer to that is, I am not a marketing person. So thankfully, I am not involved in those conversations. I just build the features. I don't figure out how we sell them. Sorry. So next section to talk about is availability. And a bit of a background story here. This is a huge section. I'm going to blast through a whole slew of features and work that we've been doing in this space. But the background to all of this is a large part of my job is going out, talking with customers, and trying to understand what features we should be building and what we should be investing in. And when we started working on Windows Server 2016, I got to be possibly the least popular guy at many of our customer site visits. Because I would go out and I would visit customers, and usually customers are fairly happy to have like Microsoft people coming out and being like, hey, what can we build for you, and so on. And they want to show off what they're working on too. And I would go out and meet with these people who were happy Microsoft customers, and I would say, so, can you tell me about the last time you had a complete cloud outage? What caused it? And just step me through that. Let me tell you, unhappy conversations. And a couple of times, I swear I almost got punched because there were a couple of times when I'd be like, when was the last time you had a complete cloud outage? And they were like, last night. And you're like, oh, do you need to go work on that? And they're like, yes. They're like, okay, fine. But one of the really interesting things, one of the startling things for me when we started digging into this was the most startling thing was everyone I talked to, and this was people using Hyper-V, people using VMware, people using open source solutions, no one had gone for more than 12 months without a complete cloud outage. Every person I talked to, sometime in the last 12 months, they'd had a complete cloud outage. Ouch. And I'll talk about some of the causes and some of the work as we dig through this. The first thing, though, before I get to that, is a bunch of work that we did around actually deploying Windows Server 2016. This has actually been kind of a personal mission of mine for the last couple of releases, because time and time again, when I talk to customers about why don't they deploy our software straight away, what's one of the biggest pain points, easily the biggest pain point is just orchestrating the upgrade process. It was really interesting when we started working on Windows Server 2012, I went out and I surveyed a bunch of customers and was like, okay, step me through what upgrade looks like. And when I was doing that, I came back to the team and I was like, okay, do you want to know what the biggest part of upgrading to a new version of Windows Server is? And they were like, oh, tell us. And they were thinking about like app compat and so on. I was like, the biggest part is getting the business approval to buy the new hardware. Like, consistently. People would tell me, actually doing the upgrade itself it's annoying and painful, but the biggest part is if you tell me I need new hardware, then I have to go through and do all the paperwork to get the business approval, and if I'm doing new hardware, then it's not long before we're in an argument about which SAN vendor we're using and why we're still using SANs and so on, and 6 months later, we finally, have hardware. So we've been working on getting to where we are today for a while now. And with Windows Server 2012 to Windows Server 2016, you can do an in-place upgrade of a Hyper-V cluster with no downtime and with no new hardware requirement. That is something I'm hugely proud of. The other thing, which, and this is, the marketing people don't like me to talk about this sort of stuff on stage, but as someone who spent so much time in the trenches, this is a big deal to me. And this is, how many people here have had this experience? You've upgraded a piece of software and everything looked okay. And you're like, this is good. And then 3 weeks later, it all blew up. And yeah, and when it all blew up, you go through and you do your triage and it's like, oh, we've got some third-party piece of software or some esoteric piece of hardware that doesn't work. You're like, okay, I'll go contact that vendor and I'll say, dude, help me out here. And you contact them, and their response is like, oh yeah, we know about that. We're working on an update to support that new piece of software. It'll be out in 3 months' time. And you're sitting here going well, there's a problem. So the great thing for me about the rolling cluster upgrade is the way this works is you take a cluster that's running 2012 R2, and one at a time, you go through, you evict a node, you upgrade it to 2016, and you go through and you do this whole process. And at the end, when everything is good, you upgrade the cluster functional level to 2016. Well, key detail here is, until you do that, you can actually roll back the whole process. So you can actually upgrade every cluster node, you can get your entire cluster up to 2016, and you can go, okay, we're going to test this out for a couple of weeks. We're going to just run, we're going to make sure all our drivers work, all our hardware works, all our tooling works, all our processes work. And if you hit that moment, you can actually then, once again, with zero downtime, go and roll the whole thing back. That is really cool. And one of the big things that we spent a lot of time discussing was, we want to get to a world where rolling out a new version of Windows Server for your Hyper-V infrastructure is a zero risk operation. We want this to not be something that makes people nervous. And so I'm really happy to see that coming out. Now, a key underpinning of this from the Hyper-V side of things is we've made a lot of changes to the way we do virtual machine upgrade. in the past, we've always had this internal virtual machine version, and we just automatically upgraded it when you bought a new virtual machine in. We've now made that an explicit operation so that you can choose, am I going to keep these virtual machines at the Windows Server 2012 R2 level, which is version 5, or am I going to run them at Windows Server 2016 level, which is version 8? And at any stage you can upgrade. You can also go through our PowerShell and you can create version 5 virtual machines on a Windows Server 2016 environment. Now this is important for two reasons. The first reason is, it's the underpinning of the rolling cluster upgrade. The second reason is, I know all of you well enough to know that I'm fairly certain that most of you don't go through and upgrade every server in your infrastructure on one weekend. Fairly certain that doesn't happen. Fairly certain that you deploy a new cluster, you upgrade this cluster, you keep old clusters running, you move and you stage, and you're responsible in managing your environment. This functionality means that if you're running in these mixed mode environments where you have different servers, you can still move virtual machines back and forward between them. And the great thing is, if you have a version 5 virtual machine, we make sure everything is compatible. Live migration, checkpoints, everything. At any stage, you can move that virtual machine back to a 2012 R2 server, and it all just works. What happened to V6 and V7? That's a great question. V6 and V7 were actually because a key detail to understand here, something that I'm really proud of, is we ship Hyper-V all over the place. It's on desktop, it's on server, it's on Xbox, it powers Azure. One Hyper-V binary. We don't fork. We don't have multiple versions. So version 6 and version 7 are actually the Windows 10 initial release and the Windows 10 November update. Version 8 is the Windows 10 anniversary update and Windows Server 2016. So from a server timeline, there's only version 5 and version 8. Version 6 and 7 were technical previews. But moving on. When we started digging into what were causes of outages and failures, there were actually two ones that really popped as leading causes of complete cloud downtime. The first one was, and this is a story everyone's heard. We'd talk to customers and they would say, everything was fine, life was good. It was Thursday afternoon. It's always a Thursday afternoon. It's sunny. And all of a sudden, the network stopped working. Packets stopped routing. And just as I was going like, what's happening? It came back. There was a momentary glitch. Networking went for a couple of minutes. And I'm like, that's weird. And then 2 minutes later, Operations Manager started lighting up because my Hyper-V cluster had fallen over because of that network outage. That's common story number one. Common story number two, similar network one. I love this one because the story is always about a colleague. It's never about the person I'm talking to. The story is always about, yeah, we had that time when Jim, Jim, Jim needed to update a VLAN table on our switch, and he fat-fingered it, and he got it wrong. And for 5 minutes, networking was on the floor. And then when it was fixed, it came back, but all my Hyper-V clusters had fallen over. So that's the second story. The third story that we heard, and this was really interesting, was a lot of Hyper-V clusters have a common shared storage. They have a SAN on the back end. They have an iSCSI device on the back end that stores all the virtual machines. And people would have experiences where there would be an issue connecting to that storage. And now they kind of understood that, like, if the storage goes away, obviously my virtual machines can't keep on running, but the problem would be that they would have an issue with the storage that would cause all their virtual machines to crash. And then when the storage came back, they would have days recovering those workloads. And I've even talked to hosters where they're like, look, we had a storage outage, happened at 3 a.m. We spent the whole next day just getting workloads back up and running. But all these virtual machines belong to tenants. We don't have login credentials for them. So when we say virtual machines back up and running, all we know is that we got them to boot to the login prompt. We don't know if the workload's in them, the databases, the websites. We don't know what's going on there. And we're relying on our customers to call us and let us know what's happening. So there's a whole suite of technology that we built for these scenarios. The first one is the feature VM Compute Node Resiliency. And this is technology we worked with the clustering team, where what we do is, for the most part, clustering is very responsive. If there's a network outage, we move resources around immediately. But because failing over a virtual machine is a very heavyweight operation, we changed the logic to say, okay, if we have a network outage and there's a running virtual machine, not an offline one, by the way, offline ones will move straight away, but if there's a running virtual machine, let's just wait for a little bit to see if the network comes back. By default, we'll wait 4 minutes. That is configurable. You can decide in your environment what you want the threshold to be. And we will show through the cluster manager that, hey, this virtual machine's unmonitored. But we will wait 4 minutes, and if the network comes back, great, everything's fine. If it doesn't, then we go ahead and do the failover. So that's the first piece of technology. The second piece of technology, one that I really love, is the VM storage resiliency. And the idea behind VM storage resiliency is figuring out how to handle these storage outages in cloud environments more gracefully. So what we do with this technology is, as the virtual machine's running, if the storage goes away, it's an SMB share, the network's down. It's an iSCSI or SAN device, and we can't access it. In the past, when the guest operating system would try and write to the disk, we would get the first fail. We would just pass that back to the guest operating system, and 9 times out of 10, the guest operating system would see that and go, well, the most reasonable thing for me to do right now is to crash. And it would bug check. And that's the experience we had today. Now what we will do is when we get that first write failure coming back from the underlying storage, rather than sending it through to the guest operating system, we will pause the virtual machine. So the virtual machine goes offline at that stage. If you see it in Hyper-V Manager, it says paused critical. But we pause that virtual machine, and we now just start retrying that operation until it succeeds. And we will actually, once again, this is configurable, but by default, we will wait 24 hours. So you can have a SAN go away, and you can spend 3-4 hours figuring out what's going on, fixing the issue. You get the SAN back up, you get it back connected, and the moment it's back up and running, we retry that operation, and bam, we'll resume the virtual machine, and it won't crash, it won't have seen any downtime, it'll be back up and running. So that's the second investment that we made there. The third investment is a feature I really like. It's a feature called Node Quarantine. So I mentioned, I talked about these network outages and storage outages being the most common cases that we heard about. While not a common case, a case that we encountered, and it was really interesting, was we ran across customers where they had a single node in a cluster that had a piece of faulty hardware. And it was faulty hardware where sometimes it'd be okay, and sometimes it would fail, and it would keep on coming in and out of good health, bad health. And what would happen is this single node would slowly destroy their entire cluster. Because the node would be good, workload would get placed on it, and then it would have problem, and workload would get failed over, and then it would be good again, and it would come back, and workload would get placed on it again. And this pattern would repeat, and slowly it would just ruin everything. And this was a really hard thing for customers to diagnose and detect. So what we do with Node Quarantine is we keep a track of every time a node leaves and rejoins a cluster without direct admin action. And if we see that happen too often, once again, this is configurable. The default we have it is if we see it 3 times in an hour. If 3 times in an hour we see a node leave and come back into the cluster and no admin's been touching it, we put that node in quarantine. And what quarantine looks like is we still keep it in the cluster, but the next time it comes back online, we will live migrate off any virtual machines, and we then mark it as a quarantine node, and we won't place any new workload on that node until an administrator comes in, checks out what's happening, and manually clears the state of that node. So that's the third technology. So those 3 technologies, one, we believe are going to drastically increase the uptime of Hyper-V cloud deployments. 2, and I really like this, is there's nothing you have to do to turn those on. So you can take your existing infrastructure that's running Windows Server 2012 R2, upgrade to 2016, and you get all of these extra levels of protection. So now, some other things we've done about availability. First, how many people here run guest clusters? Clustered workloads inside guests. Okay. How many of you are using shared VHDX? Good people, most of you. So I'm really happy with the work we've done with shared VHDX. In 2012 R2, we came out and we said, okay, shared VHDX lets you do guest clusters without the pain of LUN and iSCSI management. They're just VHDX files. But the problem that we had was there was a bunch of Hyper-V technology that we did not support with shared VHDX files. And we've been able to go through and now bring most of that across. So you can now do host-based backup of guest clusters. You can use Hyper-V Replica with guest clusters. You can do online storage resize with shared VHDX files. In fact, today there is only one feature that you lose if you use shared VHDX, and that is storage migration. But every other feature that you get with a single virtual machine, you now get with a guest cluster running shared VHDX. Another feature, how many people here use Hyper-V Replica? Okay, I'd say about a quarter of the room. So this is a minor annoyance with Hyper-V Replica, but in the past, if you were using Hyper-V Replica and you changed the virtual hard drives attached to a virtual machine, you had to do a complete resync operation. We've taken that away now. You can add and remove virtual hard drives and go through and change the replicated VHD set without having to resync the entire virtual machine. Another one, this is actually one of my favorite features in the release, is we have hot add and remove of network adapters. This was a big one that we'd talk to customers about, like, hey, what causes downtime? And one of the things would be like, hey, if I have to reconfigure. So I can now do hot add and remove of network adapters. This is there's a number of features that I like to keep an eye out for, because in my home environment, I only run release software in my personal servers in my house. In my lab, I run daily builds of Windows. And I always like to watch out for what are the features that I get really angry about not having in my lab. This is one of them. I've got so used to just being able to hot add network adapters that when I'd go to my home environment and have to use 2012 R2, I'd be like, why can't I do this? So that's really handy. Another interesting one that we've done is we've continued to work on our memory management technology. So in 2008, R2 Service Pack 1, we introduced dynamic memory, where we track what's happening inside the virtual machine, and we dynamically resize the memory accordingly. And we have a bunch of customers who are using that, but we also have a bunch of customers who aren't. Either because they have software where the software vendor doesn't support it, or they have customers who are like, no, I want to have like a fixed amount of memory and I want to know that that's there. So for those situations where you're not using dynamic memory, there are two really important changes. The first one is we now let you change the amount of memory assigned to a static VM live. So running virtual machine, you can go in and you can change the memory up and down. The second one, which is really nice for me, is even if you don't have dynamic memory enabled, we now expose the information about memory pressure and memory usage inside the virtual machine. Why is that useful? Well, it's useful because how many people here show of hands, how many people here have virtual machines in their infrastructure which they are sure are wasting memory, but they haven't been able to reduce the memory because they have a user who's like, oh no, I need that memory. Yeah. So now you can go to that virtual machine that's got 4 gig, 8 gig, 16 gig, whatever, that's using static memory. You can go in Hyper-V Manager, and we actually have right there on Hyper-V Manager, we'll be like, this VM is currently using 800 meg of memory. And you can be like, okay, let's go have a conversation with the user to be like, hey, you're only using 800 meg of memory. Like, can we look at reducing the amount of memory on it? And just providing you with that data. The final feature in availability is production checkpoints. I'm really happy about this feature. Forever, we have been telling people not to use checkpoints in production. And forever, people have not been listening to us. One of my favorite stories here. So my team and me personally, I've been the owner for VM checkpoints and used to be VM snapshots since the first release of Hyper-V. And when we first released Hyper-V, we knew there were a number of reasons why you wouldn't want to use these in production. And we documented, don't use these in production, don't use these in production, don't use these in production. And everyone ignored us, and everyone used them in production. And 6 months after the first release of Hyper-V, the #1 support call generator was people shooting themselves in the foot using checkpoints in production. And let me tell you, if you're the PM who owns the #1 support call generator, you get to meet the vice president. It's great. I got to be in meeting after meeting where they're like, okay, Ben, what are we going to do to reduce the support calls? And so we've been slowly working on addressing the different pain points here. We changed the way we store the files. We added the ability to live merge the virtual hard drives. But in 2016, the final biggest change that we've made is that we now have production checkpoints and standard checkpoints. Standard checkpoints are checkpoints as you've always known them, and they have the problematic thing for a production environment that when you apply them, we restore all the apps and services to exactly where they were, which is great if you're dev test. It's a bit of a problem if that's an Exchange server, or that's a SQL server, or God forbid, that's a domain controller. Like, you don't want all that state restored just as it was. You're going to see problems. With production checkpoints, we give you the same user experience that you have around VM checkpoints, but instead of capturing the memory, we actually utilize VSS to take a backup. Now, it is instant. It feels like, you take checkpoint, it feels the same. But now when you restore it, for all the software inside the virtual machine, it's like it's just being restored from a backup. So it's fully supported for all your server workloads. I do have to smile. I'm chuckling as I say this because literally this morning I got an email from a random program manager on the Exchange team going like, what the hell are you saying that this is supported? And I had to be like, it's okay, we're using VSS inside the guest. You support VSS, right? And he was like, yeah. And I stepped him through the whole thing, and he's like, oh, okay. And this has been a big investment for us to make sure that this is supported for all our server workloads. So unfortunately, I am going to skip over this demo. I do not have enough time to demo these features, so I would encourage you, check online. We have a bunch of this available. So next area is storage. So I've made a bunch of investments in storage. I'm going to call out a couple of high-level ones. The first one is, in Windows Server 2012 R2, we started investing in storage costs. We're continuing to invest in that in 2016. When we talk to customers, storage throughput is one of the most common bottlenecks in a cloud deployment. So what are some of the changes that we've made here? The first change that we've made is we've done a lot of work with the file server team to allow you to define storage cost policies on a Windows file server. Why is that important? Well, the reason why that's important is you can define storage cost policies on individual Hyper-V servers, and we still continue to support that. But if you have 8 Hyper-V servers talking to one file server, then those individual Hyper-V servers don't know what's happening with each other. When you define the policy on the file server, we're actually able to be intelligent and be aware that, like, oh, I've got 8 Hyper-V servers with 100 virtual machines. And what we're actually able to do is we're able to communicate between the file server and the Hyper-V server to say, hey, Hyper-V server, I don't have enough bandwidth for that. Don't waste your time sending requests over the network. And we're able to have this communication back and forth between the file server and the Hyper-V server to get really efficient both storage and network utilization out of that. The next thing that we've done is we've implemented a number of group QoS policies. And we've done 2 forms of group QoS policies, both of which solve different problems. The first one that we have is we have what we call single instance policies. And single instance policies allow you to create a single policy where you can say, you know what? Engineering department gets 10,000 IOPS. And any VM that the engineering department creates, I'm going to attach this policy to it, and they will all pull from the same pool of IOPS. So now if the engineering department has one VM go hot, it only affects other engineering VMs. And I can guarantee that the engineering department only gets 10,000 IOPS total. So that's one policy we have. The other is the multi-instance policy. And the multi-instance policy allows you to go, every VM associated with this policy gets up to 200 IOPS. Where this becomes useful is, let's say you're doing a VDI deployment, and you've set an IOPS policy, and you need to tweak and refine it. By using a group policy, you only change it once, rather than having to go and change the values on each virtual machine. So a bunch of work there. The next thing that we've done around storage is new in Windows Server 2016. We now allow you to directly assign storage devices into virtual machines. Now, obviously, there are a bunch of downsides with this. You lose things like live migration, checkpoints, so on. But the primary reason why we did this is because there's a new generation of storage coming out, the NVM and NVMe devices, where the latency on them is so low that virtualization adds a noticeable overhead. And for customers who need like the absolute lowest latency possible, they can now assign these storage devices directly through. We've also been doing a lot of work on backup. I would love to spend 2 hours talking about this. Unfortunately, I can't. The summary is, when you deploy Windows Server 2016, please reach out to your backup vendor of choice. Ask them for updated versions for Hyper-V. We've been doing a huge amount of work with all of them to ensure that they use this new infrastructure. It's going to drastically reduce the impact of backup software on your environment. It's going to reduce the number of snapshots that they take on your backend storage. And it removes the need for backup vendors to install kernel mode components on your servers, which is a good thing. So really happy to see this technology coming through. The final thing is, and I'm going to switch across to my demo system to show this off, is we've done a bunch of work with the REFS team. And the punchline while I bring this up, and I do want to be really clear on this one, is for anyone deploying Windows Server 2016, you should really be looking at using REFS for your volumes where you store your virtual hard drives. So if I bring this up, I have this system set up. This is a Hyper-V server. I've got 2 volumes attached to it. I've got an NTFS drive. I've got an REFS drive. They're backed by the same storage. The only difference is the file system. So the first thing I'm going to do is I'm going to go through, I'm going to use measure command so it can tell us how long this takes. And I'm going to say new VHD. And I'm going to say path. I'm going to make it a fixed one. And I'm going to say 10 gigabytes. So this is going to go through. It's going to create a 10 gigabyte fixed size VHD on my N drive, assuming I've typed it in correctly. Thank you. Yes. And what's happening right now is we are manually going through and writing a whole bunch of zeros. We're writing at 10 gig of zeros to the disk. And we're doing that because NTFS is really old. And NTFS was designed in a world where the idea of a 10 gig file was unusual. So if we have a look at this, let me just zoom in for a bit. You can see that, okay, total seconds, that took 26 seconds to create a 10 gig file. So now let's do exactly the same thing, but this time on my REFS volume. What you're going to see is, oh, look at that. It took a total of 1 second. The reason why the difference exists is because REFS is a much more intelligent file system. And we're able to talk to it at a much higher level and go, okay, REFS, rather than NTFS where we go, give us a 10 gig file, and it goes, okay, and then we have to go through and write out zeros. We can go, REFS, give us a 10 gig file of zeros, please. And it can go, oh, okay, I've got a bunch of zeros sitting around, and hooks them up. So we don't have to go through and do that. But more interesting to me is the work that we did around merging virtual hard drives. So I actually have, let me quickly show, I have on both these drives, I have a parent and a differencing drive. You can see it's about a 6 gig differencing disk, and I've made a copy of the same files on both partitions. So same files on NTFS and REFS. So I'm going to say merge VHD, path, we'll start with NTFS, diff, I have to remember destination path, there we go. I'm just going to merge it into its parent. So this is a merge operation, and what we're doing right now is we're going through and we are literally copying every byte from the differencing disk into the parent. So not only does this take time, but if you could see on my laptop here, my hard drive is pegged. And you might be thinking, well, I don't merge that often. Well, if you use checkpoints, you do. If you use backup, you do. If you use Hyper-V Replica, you do. There are a whole bunch of technologies in Hyper-V where we will create differencing disks and merge them in. And that takes time, but it also sucks up a whole lot of storage bandwidth. So let's have a look at this. Just a second. So doing that merge on NTFS took 37 seconds. So let's see what happens if I do that on REFS. Same files, REFS, and done. Took 3 seconds. But more importantly, it did not do anything with my disk. And why is that? Well, once again, it comes back to, I'm going to switch across. It comes back to NTFS intelligence versus REFS. So with REFS, we're actually able to go through and we're able to say, we have 2 files. Can you, don't move any of the data, just create a new file descriptor for us that is the union of those 2 files. And it goes through and it creates a new virtual hard drive descriptor without moving any of the data. So it's hugely fast, and it doesn't impact the I/O at all. So OK, I'm going to have to scream through here. I'm probably going to go a little over time. We'll see how far I can get before they kick me off stage. So graphics. How many people here have played with remote effects in Windows Server 2012 R2? So this is a great technology for VDI deployments. We have made a whole bunch of investments here for 2016. So it's now supported for Generation 2 virtual machines. We support newer versions of OpenGL and OpenCL. We allow you to have more VRAM. We allow you to dedicate to have more monitors. There's a whole bunch of features in here. One of the really cool ones is that in the past, remote effects was only available if you were running Windows Desktop in a virtual machine. We're now enabling it if you're running Windows Server in a virtual machine as well. And that is interesting if you're doing virtualized terminal server farms. So a lot of investments here. Just like we support direct device assignment for storage, we also support direct device assignment for GPU. Now, unlike remote effects, This is not virtualization, so it's one-to-one. You can only give one graphics card to one virtual machine, but that virtual machine gets full performance on that graphics card. Then, going in the complete opposite direction, we also have added the ability to create headless virtual machines that don't have a graphics card at all. This is actually really useful if you're running Nano in a virtual machine. You can not waste memory, starting up a graphics adapter. On a standard virtual machine, we spend about 10 meg of memory on the graphics adapter. You can go through and say, I'm never going to look at the screen for this. Get rid of that graphics adapter. Next area to talk about is what I like to call operational efficiency. This is a bunch of features that we've done that have made it easier to just use Hyper-V on a daily basis. My first and favorite feature, PowerShell Direct. How many people have played with this feature? Not enough. This is incredibly cool. What PowerShell Direct allows you to do is it allows you from your host to get a PowerShell session inside a virtual machine without networking, without any configuration at all. You can just go to the host, enter PS session, -VM name, the name of your virtual machine. We'll come up and prompt you for credentials, and then we give you a PowerShell session. You can do this interactively. You can also do it in your scripts. It is really powerful technology. Building on top of this, we also have the ability to do PowerShell Direct to JEA sessions, so just enough administration. This actually really excites me. And the reason why this excites me is when I go out and talk to people who are either hosters or who use hosted services, there's this fascinating friction that happens. And the friction goes like this. I, as a customer of a hoster, do not want the hoster to touch my VM at all. And in fact, I will probably go through and I will check the user accounts and I will remove any admin accounts that I don't recognize or so on and get your hands off my virtual machine. Until Friday afternoon when I accidentally changed the firewall settings and I no longer can access my virtual machine at all. And the first thing I do is call up the hoster and say, please fix my VM. This is a story we've heard so many times. So what this technology allows a hoster to do is you can build a JEA profile where you can say, OK, I'm the hoster. I want to put a non-admin account in your virtual machine that is only going to have access to networking-related PowerShell commandlets. It's not going to have access to the file system. It's not going to have access to anything else. And it is just there so that I can fix the network if you break it. And that is a really useful solution for this problem. Another operational thing, another common problem. Most of us have had this experience. You have a virtual machine. You move it, you've had it backed up, you've had it on external storage, you bring it in, you import it into your environment, and you're sitting there looking at the virtual machine and you're thinking, one of these network adapters is safe to attach to the public network, and one of them is not. But I don't know which one. And that happens because we don't allow you any way to differentiate between the two. So we've now provided the ability that you can set unique names on virtual network adapters. They're stored in the VM settings, and you can access them inside the virtual machine so you can see what's happening. We've made a bunch of improvements to Hyper-V Manager for different scenarios. We've also made sure we do full cross-version management. I really like this. If you're running Windows 10 on your desktop, you can use Hyper-V Manager on Windows 10 to manage Windows Server 2016, Windows Server 2012 R2, and Windows Server 2012. We've done similar work with the PowerShell so that if you're running Windows 10 on your desktop, you can use PowerShell to manage multiple versions of Hyper-V. We made a bunch of changes around how we distribute and service integration components. This is really interesting for me because, as I said, I do a lot of customer research. I had someone on my team was like, I want to change the way we do integration services. I don't want to do this ISO thing anymore. I want to push it out through Windows Update. And I said to them, OK, I get where you're coming at. I do have concerns. So can you go out and talk to a bunch of customers and figure out whether this works for them or not? And what we were hoping was that most people would come back and be like, yeah, integration services through Windows Update makes sense. We have some questions, we have some concerns, and we could work them through. What we were worried about was we were worried that we would get a lot of people be like, oh no, that doesn't work. What we actually got was we got about 70% of people when we talked to them said, what are integration services? And we went, right. So we are now pushing Windows integration services out through Windows Update. And that's my alarm to say I'm out of time. I'm going to keep on talking. They say I've got 5 minutes. We'll see. So for most people, this just gets updated automatically. One of the things I'm actually really happy about is in the September patch that went out, we actually updated the integration services for every workload on Windows Server 2012 R2. So what this means is that as people deploy Windows Server 2016, you don't have to upgrade the integration services. They've already been upgraded with the September rollout. So this is all just about making that easier. I was going to do a demo of PowerShell Direct. I'm going to skip over that because we're out of time. A couple of more things. How many people here have heard about NanoServer? Awesome. I have a session on Friday talking about NanoServer. The one thing I have to say here, I want to be really clear. This is our recommended deployment for Hyper-V Server. I don't want anyone coming up and saying, should we be using it? Do you guys really support this? Yes, this is our recommended deployment for Hyper-V Server. I don't want to hear, I absolutely do not want to hear about people running Hyper-V Server with a full desktop. I don't want to hear about people running Server Core even. Hyper-V Server Nano, it's a great experience, and you really want to be doing it. We also added support for nested virtualization. This is really cool. You can run Hyper-V inside of Hyper-V. Great functionality. We've made some changes to virtual machine configuration. I'm not going to go into that due to time. We've made some changes to clustering. The final thing I do want to talk about, there are two things, and then I will wrap up so they can kick me off stage. We added the ability to start building your own integration services. We had a bunch of software partners who wanted to do cool things on top of Hyper-V. We have a capability for doing that now called Hyper-V Sockets. So if you're one of those partners, please feel free to look at this and let us know. The final thing I have to talk about is scale limits. We have increased the scale limits through the roof. Just crazy numbers. And the one story I have to say with these scale limits is I did have a lot of people when we talked about these scale limits come and say, why are you doing this? Like, we're nowhere near your current scale limits. VMware is nowhere near your current scale limits. Why? Like, didn't you have better things to work on? And the answer is, it's a fun answer for two reasons. The first part of this is, the reason why we did this is actually for Azure. Because Azure came to us and they said, we have customers where they have need for supercompute scale for a 6-month project. And those customers don't want to buy the hardware because then it would become the world's most expensive boat anchor in 7 months' time. But they're willing to pay a lot for 6 months to have a VM of this size. So we built this for Azure. And the second reason I just love this is another situation where, like, yeah, we built it for Azure. The world gets to benefit because we have a single copy of Hyper-V. So that is my last slide. I do apologize. I have gone 3 minutes over time. I'd like to thank you all. I believe we have a lunch break now. So please go get lunch. I'm going to be walking around. Come find me, ask questions. Thank you.